When temperature will increase, this LED will become full bright. Now if I will touch it, its resistance will decrease. When resistance will decrease, at this point the voltage level will increase. The LED is now turning on. Now the LED is becoming bright. Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. I have this TTC 103-6D3 NTC Thermistor. Most of the time it is used with the heat sinks in rectifier circuits, in IGBT circuits. It sends the temperature of that surrounding, of that heat sink. Let's use this NTC thermistor with this transistor to indicate over temperature condition on this LED. I am using 2SC1815 transistor. We will use LED and we will indicate temperature on this LED. I will use 5 volts plus 5 volts. We will indicate on this LED when temperature will increase, it will give visible light. It is 103. That means at 25 degrees Celsius, its resistance is 10K. We will use this NTC TTC 103-6D3. 103 10K. We will connect this NTC to positive side because we need to change the biasing of this transistor. 2SC1815, that is this transistor. It is NPN transistor. We will connect to ground emitter and we will apply this signal to the base. When temperature will increase, resistance will decrease. To bring this transistor at conduction level, 0.6 volt, 0.7 volt, as mentioned in the data sheet, that it is NPN silicon transistor. When silicon transistor, that means it needs 0.7 volt. We will provide 0.6 volts. So we need a voltage divider network. One resistor, this is second resistor. And we want to turn on this LED when the voltage level will increase than 0.7 volt. So LED will be connected at collector side. We can connect at emitter as well. Now here we need to consider one thing, that when this transistor will saturate from this point to this point, maximum 0.25 volt. But we are not operating this transistor in saturation. We will operate this transistor in conduction. So we will consider that 1.4 volt will drop VCE, collector to emitter voltage, and VBE, we need 0.7 volt. I will consider 0.6 volt. So we will allow some temperature to increase until the voltage will obtain 0.7 volt. We can also control at 0.7 volt. Now if we say 1.4 volt or 1 volt, let's suppose 1 volt, this LED 1.8 volt. Supply voltage 5 volts minus VCE maximum 1.4 volt, voltage drop between collector to emitter, two junctions. For working transistor in conduction mode, we will consider 1 volt minus LED voltage minus 1.8 volt. Still we have 2.2 volt. We need a resistor here. This LED can be operated at 20 milliampere. We will consider 10 milliampere to 15 milliampere. 2.2 divided by 0.01. 220 ohm resistor. 10 milliampere current, that is good current for LED. So we will use 220 ohm resistor here. When this transistor will turn on, this LED will drop 1.8 volt, 1 volt here, remaining 2.2 volt across this resistor. In the base side, we have 10K. This time room temperature is 28 degrees Celsius, so it is 9.7. We will consider 10K because we are considering ambient temperature, and we want to allocate voltage 0.6 volt. Total supply voltage 5 volt minus 0.6 volt, that means 4.4 volt will drop across this NTC. When temperature will increase, the resistance will drop. We can see at body temperature 37 degrees Celsius, it is about 7.3 K, so resistance will decrease. .4 volts will drop across this resistor. Now we need to select this resistor. This time we will ignore the base current. We will calculate this point. 10K resistor divided by 4.4 volt. 2272 ohms resistor is allocated for 1 volt. We need 0.6 volt. Multiply with 0.6, 1363 ohm resistor. 1363 ohm resistor is required here. This time I am not considering the parallel current, that is IB, base current, because when current will flow from here in this voltage divider, it will also create a loading effect. But to demonstrate, I am just only considering this current. For a safe operation, we can also connect a capacitor here to remove the ripples. Emitter, collector, base. We will connect this LED. LED cathode will be connected at collector. You can also make this project on project board, but I am making it on paper to make it clear. Collector, at anode of this LED we will connect 220 ohm resistor. We will connect 1363. I will combine two resistors in series, 1K and 330 ohms. So it will become around 1330. This end will be connected to this emitter. This is base. We will connect this resistor at the base. It is 1363 ohm resistor, but I am using 1330 ohm between emitter to base, and between base and this point I will use this NTC. Now our circuit is ready. NTC, this resistor between emitter and base, at collector, cathode of LED, anode is connected to this 220 ohm resistor. Here we will apply positive voltage 5 volt. Positive 5 volt here and ground here. .1 volt supply. Now I will monitor base voltage. DC voltage. between base and emitter. 0.49, because this time I'm using slightly less value resistor, and this NTC is also not 10K this time, it is 9.7K. Now if I will touch it, its resistance will decrease. When resistance will decrease, at this point the voltage level will increase. The LED is now turning on. Now the LED is becoming bright. The voltage are 0.615, because we considered just only this current. Let's heat it up. Yes. When the temperature will decrease, it will turn off again. Yes, it is off now. It is off. When its temperature will increase, it will amplify a linear signal. It is linear amplifier. Basically, we are controlling the base current. If the base voltage will increase more and more, its conduction will increase, and this time the LED is full bright. When it will cool down, LED will turn off. We can add any sound warning, or we can activate any other circuit. When temperature will increase, this LED will become full bright. If you enjoyed this process, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.